All right. So the problem this time says, what volume of 0.25 molarity potassium permanganate contains zero point 0.5 grams of potassium permanganate? So that seemed kind of funny to say. So what does it even mean? Uh, so I see we have a molarity, and it's saying if you have this molarity of 0.25 and you have this amount of grams of it, what's the volume? Straightforward. So step one, identify the given information. So we were given a molarity of 0.250. We were given a mass of 0.500 grams. And we were told that we're working with potassium permanganate. So the compound formula for that is going to be K, what is that? KMnO4. Okay. And if you're unsure about the compound formula, check out my compound formula videos, because in order to do these sorts of problems where they don't explicitly give you the formula, then you have to be able to figure that out. So moving on, we're gonna go to step 3 that says apply the math or physical laws that relate to given information. So we're given molarity, and molarity itself has a equation which says molarity equals the amount in moles over the volume in liters. And we're given the molarity, and we're given the amount of mass, not the amount in moles, but we know that we can find the conversion factor for potassium permanganate and convert the 0.5 grams over to moles. So we'll do that. In order to do that, we have to do like step 5 says. And we have potassium. Oh, excuse me. I meant to write Mn. And we have oxygen. All right. So for potassium, the mass of that is 39.1 grams per mole. We have 54.9 grams per mole. And we have 16.0 grams per mole. But according to our compound formula, there's 4 oxygens, so we'll multiply that by 4 and rewrite all our totals here. So we end up with 64 grams per mole, and everything else stayed the same. Okay, and I'm going to sum everything together so that I have the total mass of potassium permanganate. And that comes out to be 158 grams per mole. So now we know the relationship of grams and moles for potassium permanganate, and we can go ahead and convert. So we have 0.5 grams, and I'm going to put that over 1. And over here, we're going to flip that ratio so that grams is on the bottom. And the reason I'm doing that is so that when we multiply, the grams cancel each other out. So once we do that multiplication, you find that grams are gone. You're left with moles, and you are left with exactly 0.003 moles. Okay, so now We should have solved for this unknown already, like it said in step 4, but we'll do that right now. And we're looking for the moles in the end. So in order to solve for moles, we'll multiply. Oh no, we're looking for liters in the end, but still, we still should multiply by liters so that we can take it from the denominator. And that gives you moles equals the molarity times the liters. And now we're going to divide by the molarity. So our equation now took the form of the volume equals the moles over the molarity. So now we can just plug everything in. We have the moles of 0.003, and we have the molarity of 0.25, and that equals 0.0127. Now, that's in liters, and that's fine. But if we convert that over to milliliters, you'll find that 0.0127 liters, put that over 1. And now we want liters to cancel, be left with milliliters. And we found in the past that 0.001 liters equals 1 milliliter. When you do that multiplication, the liters cancel, you're left with milliliters, and you're left with 12.7 milliliters. So either of the two answers are correct. It just depends on what you were asked to, what unit you were asked to give your answer in, if any. And that's it. So thanks for watching. Until next time, take care.